Hey y'all. So today's lesson is about quadratic application problems, quadratic apps. So just a few things before we get started. Using the parabola. So remember, parabola is a U-shaped graph, either concave up or concave down. Now, in a lot of application problems, not all of them, but in a lot of them, you're going to use the concave down parabola. And a few things we're going to look for. To find the maximum or the min, remember you're going to use the negative b over 2a. So a lot of times when it asks for the maximum, you're going to start with the negative b over 2a. Now remember, this is the x value in that ordered pair. Then to find the y value, you plug this in. You plug it into your equation to find the y value. So that's how you find the minimum value or the maximum value. You're going to find the time when it hits the ground. So you know we've been factoring quadratics to find the zeros. So when it hits the ground, that is considered a zero. Because if the parabola looks like this, and it's going up and then coming back down, so that's when it hits the ground. And so you might have one or you might have two. And you need to know which one is the independent variable and which one is the dependent variable. It's very important. They might not use the variables x and y. They might use t for time, or they might use h for height, or they might use p for profit. But you're going to have to decide which one is the independent variable, which one is the dependent variable, to help you learn how to solve the problem. So I have 3 examples for you. I'm going to walk you through. All right. These are all word problems, so I expect you to write them down. A baseball is popped up by a batter. The height of the ball above ground is given by, and then you have an equation, negative 16t squared plus 64t plus 3, where t is the seconds after the ball leaves the bat, and y is the height in feet. So a couple of things are going on. The negative right here means it's a concave down parabola. And that should make sense because if the ball is getting hit off the bat, the ball is going to go up and then come back down. So whenever you have the negative in front, that's going to be a concave down graph. Now it's negative 16 because it's talking about gravity. This value right here is the y-intercept. That is like your initial amount, your y-intercept, your starting amount. So let's say, and the t is seconds. So let's say seconds are 0. At 0 time, you would have 0 plus 0 plus 3. So at 0 seconds, like as soon as this ball hits the batter's bat, it's at 3 feet, which must mean he's holding the bat at 3 feet above the ground. And that would be 0 seconds because it says seconds after the ball leaves the bat. And then h is the height. So if we're looking at time and height, time would be your independent variable, height would be your dependent variable, because depending on the time, the height depends on the time of the ball. So let's answer some questions. What is the max height? Now, the max height is going to be the y value in this case. We're looking for the y value. So we need to first do the negative b over 2a, and then we need to plug it back in. So let me show you the negative b over 2a. Negative b is negative 64 over 2 times a is negative 16. So you're going to type that in. This would be negative 64 over negative 32, which is going to be 2. So that is your x value. So to find the maximum height, we would plug this in. Plug in. So I'm going to take this equation and I'm going to plug it in. Negative 16, 2 squared, plus 64 times 2, plus 3. So you would type that in. And the max height, when I plugged this in, I got 67. So the max height is 67 feet. That is the max height. Now I can't use 2 because that is the x value. That is the independent variable. When will the ball be at the max? When? So we're looking for the time, which is the x value. Well, we already figured that out. It would be negative b over 2a, so the answer would be 2 seconds because we already found it right here. 2. These go together. At 2 seconds, it's at its height. Go over 2, up 67. When, so we're looking for time, when will the ball hit the ground? So if this is your graph, we're looking for that right there. And so you could either try to factor this to find the zeros or use the function on the calculator where we type it into y equals and we find the 0. And so I've already done that only because I didn't want to use a lot of time, but I'll just remind you, negative 16 x squared plus 64x plus 3. And when you graph it, you see the parabola. And then, you see the parabola, and so you want a second calc, find the 0, and remember we practiced the left bound and then the right bound, and then it looks like when will the ball hit the ground? The ball will hit the ground after 4 seconds, and I got that by finding the 0 on my calculator, and we practiced that. All right, copy this down. All right, so an object is launched from a platform 80 feet high. The path is modeled by, here's another quadratic equation. Notice it didn't tell me what my variables are, so I have a variable of t and I have a variable of h of t. So t is going to be the time and h of t is the height. What is the initial height? So the initial height is going to be 80 feet because it says that it was launched from a platform of 80 feet high, plus it's this value right here. What is the max height? So again, it's looking for the y value. So we have to find negative b over 2a and plug it in. Negative b is negative 64 over 2a. This is negative 16. And it comes out to be 2 again. That is your x value. Then you plug it in. So we're going to plug it in to negative 16, 2 squared, plus 64 times 2, plus 80. And the max height is 144 feet. I got that because I used my vertex point and then I plugged it back in to get the max height. When will it hit the ground? So again, I'm looking for the t. When it hits the ground, so when is the whole function equal to 0? Because remember, those are the zeros. So you type it into your y equals, you graph it to look and to find out, okay, I'm graphing it, I can see it's going to be over here, so you do second calc, your 0, and then you have to find your left bound, sorry, I went too far. All right, your left bound, your right bound, I'm sorry. And it's going to hit at when t equals 5 seconds. So that means whatever we launch is going to go up in the air and then come down, and in 5 seconds it's going to land on the ground. All right, so one more. The profit from selling tickets depends on the ticket price. So we have the profit is your dependent variable and the ticket price is your independent variable. Use the function where X is the ticket price. So X is the ticket price, P is the profit. What ticket price gives the max profit? So we're looking for the ticket price. That is your independent variable. That means we're looking for the negative B over 2A. You don't have to plug it back in. So negative B would be negative 600 divided by 2 over negative 15. So negative 600 divided by negative 30 is 20. So that means that it would be a $20 ticket price would give the max height. This is your independent variable, so that's your X value that you're looking for. What is the max profit? So we're looking for the dependent variable. That means we have to plug 20 back in. So I'm going to plug 20 back in to my function to find the max profit. So negative 15 times 20 squared plus 600 times 20 plus 60. And that means the max profit is $6,060. $6,060. If they can sell if they can sell tickets at $20 a ticket, then that will be their maximum profit of $6,060. So the things that you should get from this lecture are how to use the vertex point. When are you looking for the negative B over 2A? When do you have to plug that back into your equation? How to find the max and min, and how to find when it hits the ground. And we're going to practice more of these in class.